Hello, I welcome you all to today's lesson. We continue with complex numbers. This is a topic that we are dealing with. And in today's lesson, we are going to talk about the Argand diagram and polar form of a complex number. This is what we are going to start with. So as you can see, the first thing that you need to know and consider is the Argand diagram. What is an Argand diagram? So an Argand diagram, this is a plane which we call that helps us plot a complex number. So a plane that helps us plot a complex number, it is called an Argand diagram. It is like this. This is a plane that helps us plot a complex number. So when you have something like this, we've got a plane. Let's say I'm going to put a simple plane like this. This is a plane. So we know that we need to have the x-axis and the y-axis, but in this case we don't have those. But this one, it is called the Leo axis. We call it a Leo axis. This one here, we call it an imaginary axis. Have you seen the difference? So this is what we call an Argand diagram. So the y-axis, it is called, so the y-axis is called the imaginary axis, and the y-axis, it is called the Leo axis. So let's say you are given a complex number. So just a simple diagram. So this is you are given some 3 plus 2i. You are told to plot that complex number on this Argand diagram. How can you plot that? You know that this is the what? The real axis, or this is the real number. So this one, 3 will fall under the real axis because this is the real part. Imaginary part is 2. 2 will fall there. This is where it is going to fall, a 2. So meaning that this point is there. Have you seen? This is where these two are joining. This is where these two are joining. So the point is there, the point Z, which is equal to 3 plus 2i, like that. I don't know if you've seen the difference here, if you've understood the concept. Let us look at another question. So what if you are told to plot this? So you always plot on the plane we call the Argand diagram. So you want to plot that. So how can you plot that? You do something like this. So these are we are just sketching here like this. You know that this is the real axis. You know that that is the what? Imaginary axis. You know that that's the imaginary axis. So 0 definitely is there. So 6 in the real, I'll put a 6 there. Then in the imaginary there, imaginary part, 3 is somewhere there. So I'm going to put a 3 somewhere there. So where this point and that point, the point is somewhere where? Somewhere there. So this is where I've got the point Z, which is equal to 6 plus 3i, like this. I don't know if you've understood this, if you've gotten the point. This is what you need to know on the Argand diagram. This is a plane that we call, that helps us plot a complex number. So when you are told to plot a complex number, you need to know the Argand diagram. This is an important diagram that you need to know. This is a plane that helps us plot a complex number. It is called an Argand diagram. So this is what you need to know and understand. So now, on the polar form of a complex number, how do we express a complex number into a polar form? What are we supposed to do, or what are some of the things that should be considered? So if you want to change a complex number to a polar form, what you need to do, so I want us to build from somewhere so that you know where these things are coming from. So let's say you are given something like this. Have you seen? We've got a point there. I'll call that point P. So you know that x comma y. Then this is there is an angle theta there, which is the theta is there. We've got a theta there. Then here, when we try to bring down here like this, we know that that is the y-axis and that is the x-axis. Then here, from here to there, we've got a radius. We've got a what? We've got a radius. So from here to there, we've got a radius. I'll say this is what? This is r. Or this is called the modulus of z. It is just one and the same. Because how do you get to find that? You need to say square this and that. Then you say, if we were to find that, we say r is equal to x squared. R squared is equal to x squared plus y squared. This is what we know. So we know that r is equal to square root of what? X squared plus y squared. We know that this is just the same. Then the r which I wrote here, you know that the x on the complex part, when I wrote a complex number like z is equal to x plus I y. Have you seen like that? So there is x here and y which is there. So this is just the same as z. Have you seen the modulus of z, which is equal to this? This is just one and the same thing. So this is just one and the same thing. Don't be confused. So don't be confused on that part. So this is the radius. This is the radius. Have you seen? So we've got this part. We also have this part. So if we remember trigonometric ratios during our secondary level, when we were doing O levels, we know that there is what we call SOHCAHTOA. This one will really help us to understand this. We get to call this as SOHCAHTOA. It is like this. This is how it is. We call it SOHCAHTOA. So we know that, let's say, what do we call this? This is what? Have you seen this? This is opposite to this angle. Y is opposite to the angle. Where do we have the opposite? We've got something like this. Have you seen here? So whenever you want to find the y there, what we get to do, we say y is equal to the radius here. Have you seen the radius? So we say y is equal to, how do we find y? How do we get to find y? So what we get to do is this is what we get to, we say radius, then sine what? Sine theta. This is what you need to understand on the y. On the x here, we covered these things. I hope you are not confused. So how do we find, this is the x-axis. Have you seen x-axis here from here to there? So we say r, then I say cos. Cos what? Cos theta. This is what I need. So in the x-axis, it is r cos theta. In the y-axis, from there to there, this is part of the y-axis. It is r sine theta. This is what you need to know and understand. This is what we need to know and understand. Hope you are not confused on this part. Maybe I explain more on this. Listen, when I get this part, have you seen? This is what? This is the so it is sine theta is equal to opposite over hypotenuse. Maybe I explain a bit. Maybe someone who is confused on this part. So I say sine theta is equal to, we are talking about this part. Sine theta is equal to, what is our opposite? Our opposite is y. Y there. So I say y over. What is the hypotenuse? Hypotenuse is this one. Here we've got a right angle. So that is my hypotenuse. This is what? R there. So if I cross multiply, what am I going to have when I cross multiply? I'm going to have r sine theta is equal to what? Is equal to y, which is just the same as that one, which I've written there. Have you seen? So these things, we don't just guess them, but we can prove them like the way I've shown them. So I'm simplifying this to your level so that you understand. But you did this under trigonometry. in semester 1. I believe we understand this. Even this one, this is, have you seen, this is adjacent to the angle there. So you know adjacent is there, so you go to cos. Have you seen? You just say cos theta is equal to adjacent x over hypotenuse y there. If you cross multiply, r cos theta is equal to x. This is what I've just written here. This is just one and the same thing. So this is a diagram that you need to know and understand. Hope you've understood this part. So we want to learn on how to change a complex number to a polar form. So what you need to do, first thing is find the radius. How do we get to find the radius? So the radius, that's the distance from 0, the origin, to a point. Have you seen? So whenever we are talking about the distance, we are talking about the distance, which is the modulus. So how do we find that distance, which is what? R, the radius. So it is from the origin here to the point what? Point P. How do you find that? So we say radius is equal to, this is what we get to, radius is equal to what? We know that it is the modulus of what? Modulus of z, which is just equal to what? Is where you square the x and the what? And the y, like this. You put them under this root. So this is how you need to find the what? The radius. Know this part. So the first thing you need to do is to find the radius. We want to change a complex number to a polar form. First thing, find the radius. This is the formula that we get to use, and this is what you need to understand. Have you seen? So here on the complex number, a complex number is like this. So I do this. A complex number is like this. This is how a complex number is. Complex number is equal to x plus y z. I mean iy, like this. So now, if you want to change to a complex, if you want to change to a polar form, where there is x, you're going to put that. Where there is y, you put that. So in other words, what we are going to have is z is equal to x, you know it's r cos theta, plus I r sin theta. This is what we are going to have. So r is common. So this is now equal to what? Factor out r. We are going to have cos theta plus I sin theta. So this is in polar form. So this is what? The polar form that we are talking about. This is the polar form. So you need to make sure that it looks like this. When you change a complex number to this, meaning that you've changed it to a polar form. So if you are able to see certain things here, we've got r there. What is our r? Radius. I've given you the formula to use. The other thing remaining is what? The other thing which is remaining is the what? Is the angle there. Have you seen? So this is what you need to do. The angle. How do you find the angle? How do you find the angle? So the way we get to find the angle is like this. The way we get to find the angle. So let me just show you how to find the angle now. Since I've shown you the way in which a polar form should look. So how do we now get to find the angle? So the angle, we say tan theta is equal to y over x. We use this formula. This is the formula that is going to help us answer such a question. This is what will really help us handle such a question. So this one is also called the argument. The angle is called the argument. So we need to find the argument. So the argument is the what? Is the angle. So don't be confused when I say we need first to find the argument of this complex number. So the argument, that's an angle. So we are talking about an angle. This is what you need to do. And the good part is that you also did part of this under trigonometry. So you won't find any difficulties under this topic. You won't find any difficulties on finding the argument using this. So now, let us now look at an example. Let us now look at an example. Okay, so we are given this question here saying express this complex number z is equals to 2 plus 2i in 2 polar form. How can we express this in 2 polar form? The first thing that you need to do, find the radius. Radius is equal to x squared plus y squared. You know that this is x, that is y. So this is just the same as 2 squared plus 2 squared. What answer are you going to have? You are going to have 8 there. So this can also be written as this. We've done sides. This can also be written into, you can say 2 times 4. It's just the same as that. Where you know that this is now the same as, root 2 root 4. And when we express it nicely, we are going to have what? 2 root 2. Because the square root of 4 is 2. So this is the answer that we have. So this is the radius. After finding the radius, we need to find the argument. We need to find the what? The argument. So how do we find the argument? We say tan theta is equal to y over x. So tan theta is equal to, what is your y? 2. What is your x? 2. So this is just the same as tan theta is equal to 1. Have you seen? Then tan moves to the other side there. So it is like this. So if you want, you can just write it here direct. Like where you say, for you to find the argument, which is the angle, you just say this is equal to tan inverse of y over x. Just one and the same. Have you seen? Because you're going to reach at a part where this is now will be equal to. So when you reach there, you're going to have theta is now equal to tan inverse of, if you divide 2 divided by 2, it is 1. Have you seen? Just one and the same. So instead of doing this, you can just get this part. Just, we are getting the same answer. You can just go straight to this where you say inverse there. So there, what is your theta? What is your theta now? So angle for tan, that gives us 1. This is what it means. So we've done this under trigonometry. So the angle for theta, for tan, that gives us 1. It is what? It is 45. Tan 45 is 1. I believe we know that. Tan 45 is what? Is 1. So that is 45 degrees. So the angle there is what? 45 degrees. We found the radius and the angle, which is the argument. So this is what we've done. So what we've done, we found the angle, which is the argument for this. What is the argument there? The argument is 45 degrees. And the radius, what is our radius? What is our radius? Our radius, we said it was 2 root 2. This is what you need to do. This is the first thing you need to find. Then after you find these two, then you know that a complex number is written in this form, where you said polar form, we say radius, open bracket, cos theta plus I sin theta, like this. Where you now say this is now equal to 2 root 2, open bracket, cos 45 plus I sin 45, like this. So you've changed now. This is what? This is your answer. You've expressed in what? In polar form. So these are degrees. These are degrees. So you've expressed that complex number to a polar form like this. This is what you just need to do. So changing now from a polar form to a complex number, you just find the value there, then you start multiplying. You discover that you get back to that. If I tell you to expand this, the answer that you are going to find will be like that. So changing this to that is very simple, because there is no need of finding the angle, finding what, no. That is very simple. Have you seen? Just like this, you are done. So we've learned how to change a complex number into a polar form. I believe you are able to answer now questions in an exam. So this is what you need to do. This is what you need to get. Thank you so much. So let me give you now questions that you are going to practice. Let me give you exam questions that you people are going to practice. I see if we've understood this. So you just need to get a concept. So don't expect an exercise to be exactly the same, but it should be somehow challenging so that we test your mind if you've understood this. So let me give you some questions that you are going to practice. And those of you that are looking for tuitions, you can contact me. If you want to be part of the group that I do mentor, you can contact me. You WhatsApp me on this number. This is the number that you can reach me at. So you WhatsApp me on this number. You WhatsApp me on this number. Then I'll be able to help you and see how I can help you. Thank you so much.